All right, so now I'm going to move on to the next set. I'm just going to go through a couple of these. Let's see, I'll go through 34, 37, and 39. All right, so for 34, remember, when we're adding fractions, we need to have common denominators. So we need to have 3 and 15 be the same, 5 be the same number. So that means the least common multiple is 15. So I will multiply this by 5 over 5, and I will multiply this by 3 over 3. This way we get our common denominator. So now I have 5b over 15 plus 3b over 15. I can then combine our top, our numerator, our like terms, so 8b over 15, and that will be our final answer. All right, the next one that we're going to move on to now is number 37. So let me erase this. If I'm erasing this too quickly, you just need to pause the video then. All right, I now have three fractions, n over 2 minus n over 4 plus n over 6. Right now, when I look at these denominators, the least common denominator for these is 12. So that means I need to multiply this by 6 over 6. I need to multiply this one by 3 over 3. And then this last one I need to multiply by 2 over 2. So this will give me 6n over 12 minus 3n over 12 plus 2n over 12. 6 minus 3 is 3n plus 2n is 5n, so our final answer is 5n over 12. Once again, I'm going to erase this now. If you need to relook at this, then you need to pause the video. I'm trying to make these videos as short as possible and get through these as quickly as possible. All right, the next one is x over x minus 3 plus 5 over x plus 2. Right, when we have binomials or trinomials, you do need to factor sometimes, but these are already factored out. And since there's no other factor that we can get out of these, we just need to multiply each by the opposite denominator. So x plus 2 over x plus 2 times x minus 3 over x minus 3. So then we'll distribute this in, so we'll get x squared plus 2x over, you do not need to multiply your denominators, and you leave these actually not multiplying, plus, and it'll be 5x minus 15 over x plus 2 times x minus 3. So you do not have to actually multiply your denominators in. Once we get like denominators, we can then add our like terms. So now I'm left with x squared. 2x plus 5x is 7x minus 15 all over top of x plus 2 times x minus 3. The reason why you do not multiply it in is once you get your numerator, you need to see, can this factor? So we have negative 15 and 7. Well, there's no numbers that multiply to 15 that have a difference of 7. So this cannot be factored. But if it could, then you would factor and see, can I cancel out any of my factors in my denominator? If you multiply these through, you're going to have to just factor them anyway, which means you're going to have to undo some work that you're doing now. So you do not need to multiply your denominator in, but your numerator you do. And then you need to see, can this factor? If it can, you need to factor and reduce and cancel out any of your like factors. If it can't, then that is it. All right, let's move on to the next type. All right, so for these next ones, I'm only going to go through one of them. I'm only going to go through this one. All right, so we have r over 2 divided by 2 over r. Well, remember, our rules for division is we keep our first fraction the same. We change it to multiplication, and then we take our reciprocal of the second one. So although it looks like these are going to cancel out, they really won't because it's being multiplied by r over 2. So r times r is r squared, and 2 times 2 is 4. So in this case, here, you would just multiply like you did here. You can reduce if you can first, and then multiply. Here, you just need to distribute your power in, and the same thing here for the one that we did. All right, if there is anything that you can reduce beforehand, you can, but in this one, there wasn't. All right, let's move on to the next set. All right, expand and simplify. So I'm just going to go ahead and do this problem, 46. So we have x plus 1 times x minus 2. Then it's being subtracted by x plus 3 times x minus 1. So the first thing we're going to do is multiply everything. X times x gives me x squared. This will give me minus 2x and then plus x, so it's just minus x, and then minus 2. I know I just went through this by skipping a step, but we have learned this already. And I have faith that you guys are all able to multiply these on your own. But x times x is x squared. Minus 1x plus 3x, so it's plus 2x, and then minus 3. Right? The reason why I kept these in our parentheses is we are subtracting this. A lot of you guys in your test, when you did this throughout the years, you started to re-multiply these. That's not what you're doing here. We need to now distribute this negative sign in, and then it turns to an addition problem. So it'll be x squared minus x minus 2. Negative times x squared is minus x squared. Negative times 2x is minus 2x. Negative times negative 3 is plus 3. And now we will combine our like terms. Well, here we have x squared and negative x squared, so that is cancel. Negative x and negative 2x, so that will give me negative 3x. And negative 2 plus 3 gives me plus 1. Final answer. All right, I'm going to erase this and move on to the next set of questions. All right, so the next one I'm going to do is this question number 49. So in order to do this, first you have to do your Pascal's triangle. And since our power is 4, I need to do it to the 4th row. So we did this throughout the year. If you do not remember this, then you can always go back to any of these videos I made throughout the year. So you have access to every single one of these. So if you forget Pascal's triangle and you don't remember or understand what I'm doing now, then go back to the original video. All right, but that means we're using this row. So I know I'm going to have the coefficients of 1, 4, 6, 4, and 1. Then this, I think about it as if it's a plus b raised to the 4th power. So I start with my a gets raised that power, and it loses 1 power every single time. My b starts at 0, and it loses a power, or gains a power every single time. And we're always adding in the beginning, when we're doing the formula, we're always adding these numbers. Now we're going to substitute in. Well, a was written first, so a is equal to 2x. B was written second, so b is equal to negative 1. So I'm going to go ahead and substitute this in. So it's 1 times our a, which is 2x, raised to the 4th power. Our b gets canceled out, plus 4 times our a, which is 2x, cubed, times our b, which is negative 1. I might run out of space, so I'm just going to move this over. Plus 6 times our a, which is 2x, squared, times our b squared, which is negative 1 squared, plus 4 times our a raised to the 1st power, which is 2x, times our b raised to the 3rd power, so negative 1 cubed. And then it'll be plus, let me just move this over just a little bit more, plus 1. We don't need to write our a since it's to the 0 power, and that's 1, times negative 1 to the 4th power. All right, now I'm going to go ahead and do all my math. 2 raised to the 4th power is 16. 16 times 1 will give me 16, and then this x to the 4th power is x to the 4th. Here, 2 raised to the 3rd power is 8, times 4 times negative 1, so this will give me minus 32, x cubed. X is being raised to the 3rd power. Here, it'll be 4 times 6. Negative 1 squared is positive 1, so plus 24 x squared. Here we will have 4 times 2 times negative 1 because it's raised to a negative or odd power, so it'll be negative 8x. And here, negative 1 to the 4th power is just plus 1. And that will be your final answer. All right, just like I was saying, if you are having trouble understanding or remembering this, then you're just going to have to go through the video that I created for this in the regular school year. All right, so now I'm just going to pick a few of these factors. So we'll do 50, we'll do 53, we will do 55, and we will do 52. All right, it's one of each type. So for 50, 2x squared plus 4x, first thing we do is we look for GCF. So we have a 2 goes in both of these, and we have an x, so we can factor out the 2x. Then we're left with x plus 2. So that is fully factored for number 50. All right, let me erase this. Let's move on to the next one. 4 minus x squared. So remember, we always want our x squared to be positive. So the first thing I'm going to do is factor out a negative. So it's x squared minus 4. Then, since it's 2 terms with a subtraction, so we look and see, well, is it a difference of 2 squares? Well, the square root of x squared is x. The square root of 4 is 2. So yes. So now we can write our negative 1 that we already factored out. And then we know the difference of 2 squares factors out into 2 binomials. We write plus or minus in between. And then our 2 square roots get written. So it'll be x plus 2 and x minus 2. And that will be our fully factored problem for 52. All right, moving on to the next one. Same thing. If you need to write these down, just pause the video. I'm moving as quickly as I can because it's a lot that we need to cover or go through. And I'm trying to just make these videos as quick as possible. So in this one, whenever we have 3 terms, one of the things that we talked about before, well, if our first and third terms are positive, which they are, then we can see, well, is this a perfect trinomial square? So we take the square root of first and third. It's 2x and that's 1. So yes, we can take the square roots. Then we multiply them together. 2x times 1 is 2x. Then we always multiply it or double it. So that will be 4x. Then we see, does this match our middle term? It does. So that means this is a perfect trinomial square. When that happens, we write a binomial and we square it. Well, the two square roots, 2x and 1, get written. And then the sign that we have in the middle is a sign that goes here. So it factors out to 2x plus 1 squared. All right, then the last one I'm going to do for this bunch, number 55. Here we have negative x squared plus 7x plus 60. Remember, we always want our x squared to be positive, so I'm going to first factor out that negative, so that way we have our positive x squared, and all of our other signs change. Then we're going to use our x method. You can use any method you want. Well, 1 times negative 60 gives me negative 60. The negative 7 drops. Numbers that multiply to 60 and have a difference of 7 are 12 and 5, and since this is negative, our larger number has to be negative. So when we divide it by the number in front of the x squared, which is positive 1, and now we started from the bottom, now we're here. So we had the negative that we already factored out, and then we started from the bottom, so it's 1x minus 12 times x plus 5. That is your fully factored form, and that is the only way, the only answer for this. All right, let's move on to the next ones. The next ones, I'm actually going to go through all three. I'm going to try and go through these quickly. Or no, I'm only going to go through 57 and 58 because 59 is included with this 58. So 57 and 58. All right, 57 is really easy. You may think it's hard, but it's already set up for us to solve. So it's 5x plus 8 squared is equal to 25. Well, anytime we have something squared, we can just take the square root of it. So if we take the square root of each side, we isolate because this will undo the square root, will undo the square. So we're left with 5x plus 8. And remember, when something squared is equal to a number, it generates a positive and a negative because 5 squared is equal to 25 and negative 5 squared is equal to 25. So this generates a plus and minus 5. So then we have to solve two different answers. 5x plus 8 is equal to a positive 5 or 5x plus 8 is equal to a negative 5. We can then subtract the 8s. So we get 5x is equal to negative 3 or 5x is equal to negative 13. Divide everything by 5. And we get x is equal to negative 3 over 5 or x is equal to negative 13 over 5. If I ask you to round, then you can round. If I ask you to leave as a fraction, you can leave it as a fraction. If this were to ask you to write this as a decimal, it will be negative 0.6, or this one will be negative 2.6. All right, let's move on to 58 now. Just erase this. All right, so for 58, it's a little bit more challenging. For 58, it's not set up with something squared, but it's saying x times 4 minus x is equal to negative 21. So in this case, we actually need to multiply this through first. We need to get rid of the factors. We can't solve it with factors unless it's set equal to 0, which it's not. And we just add over 21. It's no longer factors. So then we get 4x minus x squared is equal to negative 21. When we see that we have something squared, unlike this one where it was there's nothing else on the side that was adding or subtracting to it, that's why we could just take the square root. Here, there's something being added to it. So we need to go ahead and use our quadratic formula, factoring or completing the square. So in order to do this, we need to set it equal to 0 first. So we want our x squared to be positive, so I'm going to add this over and subtract over the 4x. So then we get x squared minus 4x minus 21 is equal to 0. All right, then we will go ahead and factor this. So this is going to factor out to x minus 7 times x plus 3 is equal to 0. We set each factor equal to 0. X minus 7 is equal to 0, or x plus 3 is equal to 0. So x is equal to 7 or negative 3. All right, that is going to be it for this video. And I'll do the rest, or it'll probably be 2 more videos I make for this.